Great. So who here thinks S3 by itself is a data lake? Raise your hands. Please don't. A data lake by itself is actually quite more than just S3, right? Because if you're just chucking objects into S3, you're really just creating a data swamp, right? And we're here to talk about what actually you need to build on top of S3 and other, say, object stores to really create a secure and compliant data lake upon which you can perform analytics. So I'm Tony Nguyen. I'm a big data consultant with Amazon Web Services, and I'm going to talk to you about all that stuff. And we're going to break it down to 4 phases during this session. So first, we're going to understand the value prop for our data lake and how AWS can help. Then we're going to get a sense of what is required to have a successful data lake implementation. We're going to then listen to a public sector customer's vision around their data lake strategy and their successful proof of concept on AWS. And we're also going to learn one way to do it in AWS with a deep dive into the proof of concept implementation we created for this customer. So traditionally, analytics looks like this, right? You have a bunch of data silos, typically disparate databases, all flowing into a data warehouse. It might be relational data you stuck into there. Typically, it's terabytes to even possibly petabyte scale in size. The schema is very rigid, right? It's defined prior to data load. And it's typically only ever used for operational reporting and ad hoc sort of query. And the downsides of this kind of architecture are that you have a really, really large initial CapEx cost, and you also have continual OpEx costs, which aren't cheap. And this is the way things have been going for quite some time, right? And as time evolves, technology evolves, requirements evolve, and new requirements now break the traditional approach upon which we need to look at our data. So our requirements, our business customers, all this stuff kind of think about these new and innovative sorts of use cases, such as capturing and storing new non-relational data at the exabyte scale, securing and combining data from new and existing sources, right? No longer are we looking at data as something that just happens as a consequence of our business. It's something that is actually of value, and we want to combine that data with other data sources so we can get even more value out of that data. And we also want to do new kinds of analyses on this data, so machine learning, big data analytics, real-time analytics. And the issue with data warehousing, right, is that it's not really optimized for these kinds of use cases. That's not to say data warehousing is being replaced by a data lake, but that's to say that there are certain things that data lakes can do better than data warehouses. And that's why we're all here, right? This is the packed room. Everyone's interested. So let's talk about exactly how data lakes extend the traditional approach, right? You can ingest relational as well as non-relational data. In fact, you can ingest any data you want at all, right? You don't need to define the schema upon ingest. You can define it upon read. You can look at it in the terabytes as well as the exabyte scale. You can apply any sorts of tools you want against the data itself, right? That separation of storage and compute is really great here. No longer am I bound to that particular technology stack that is associated with a data warehouse. I can now leverage Hadoop. I can now leverage SAS. I can now leverage whatever tool I want to analyze my data. And the best part of all, I think, for a lot of people is that it's really low-cost storage, right? You can just start throwing data in there today and start playing with it. The time and cost for entry is very, very low. And I think this makes it really appealing for a lot of customers. And just to hit on this point again, S3 by itself is not a data lake, okay? It's not enough to store. Data needs to be discoverable. Data needs to be cataloged in some sort of way and needs to be secure and needs to have some sort of control over it such that you can actually manage your data. By throwing it into S3 by itself, you aren't really enabling that. You're just, really, the analog is kind of, you have a child who you're saying, okay, I want you to sort all your stuff in a logical way. Well, some kids might want to just throw it all into the closet. Hey, it's a data lake. No, it's not. You want some sort of way to organize your data. So how do we map this to AWS? And so some of you, probably most of you, have seen this kind of diagram where there are some key sorts of pillars for a data lake. And by itself, it's kind of like, okay, cool, things can point and ingest and be pointed at various things in the data lake, but I want to go deeper into it. I want to show exactly how data flows in a data lake. So typically, you have data and you want answers from the data, right? That's really what your business is all about. So there are 4 phases. First is the collect phase. Then there's a storage phase where you're actually storing the data. You also have a process and analyze phase where you're using tools like Hadoop and SAS. to process against the data, and then you eventually have that, the results of those processed end results into some format that someone can consume, such as a visualization engine, something like that. And one thing to note here is that it's not a single continuous flow, right? There's an iterative process in the middle where you store, you process, analyze, the results of that process go back into the storage, and you keep iterating over and over against your data so you can gain more insights as more data comes in. So a typical example would be, say, machine learning, right? You initially have an initial training set, and as you have more data come in, you can refine and further refine that data as more comes in. And there are a couple other key considerations here in this pipelines, right? There's a time to answer, which is the latency, the cost associated with the pipeline, as well as the throughput, right? How fast can this data actually go through? So here is a reference architecture for how you can map actual AWS services and third-party products to that flow I showed before. And one thing you'll notice here is that things go from left to right, right? You have things that are stored within, that are collected, say, using your IoT sensors down there on the left, and they can bubble into Kafka for storage, and then those can go into S3, and then you can process, analyze them, and then you can consume them eventually. And for a lot of people, actually, they think that this is the authoritative answer to what a data lake is, and it's not, right? This is a great diagram to show how you can map technology to fulfill certain architectural requirements, but it's not answering the big questions, right? Big questions for a lot of people in the room probably are, how do I secure my data? How do I search on that data? How do I ensure that I am fulfilling all my compliance requirements on my data while also, letting all my users and analysts and such be able to access my data? So we need to take a step back. We need to establish a data strategy first, right? And one thing to consider is that, in fact, 80% of what we consider analytics is not actually analytics, right? The actual effort that is taken, say, doing notebooks with Jupyter or doing some sort of insight gathering from your data is actually quite minimal. A lot of the work you're doing is actually pre-processing, storing, ensuring security controls, all that stuff. And this is, frankly, undifferentiated heavy lifting. This is stuff that everyone can do and has to do, and it's not unique to your business. So we want to accelerate the 80% so that we can focus on that 20%. And so the key components of a successful data strategy are as follows, right? You have 1 to 10 there, and we'll go through each of them, so don't feel the need to take a picture right now. But all of these map to those key tenets of a data lake, right? You need to have entitlements for your objects in S3. You need the ability to catalog and search on those objects. You need to have some way of storing and processing streaming data. All these map to those core tenets. So let's go ahead and go through each one of those, right? And one thing that I really want to make sure that people get from this presentation is that I'm not just going to throw, oh, these are 10 key components of a data strategy, enjoy, figure it out. What I'm going to do is map each one of those tenets to services as well as third-party tools that you can use. So first, automated and reliable data ingestion, right? This is the initial data gathering. This is the part where you want to pull in data into your data lake. And so from the AWS services, we have Kinesis, right? Our streaming service. We have Direct Connect, the way for you to pipe from your on-prem environment to AWS. Snowball, in case you have, say, our existing petabyte scale data that you just want to ship over, right? SneakerNet is still a thing today. As well as our database migration service, where let's say you have a bunch of databases on your on-prem environment today, and you want to migrate them into AWS. One interesting thing about the database migration service is that you don't have to point at a database for the target. You can actually point at S3 for the database migration service. So in fact, that's a very efficient way to actually pull data from your on-prem databases today into S3. You'll also note that I have some services, or rather some tools here that are not AWS services. And what I want to drive home here is that AWS is a builder's platform, right? We encourage whatever works best for your use case and your business is what we want for you to use. So if Scoop is the better answer, use Scoop. If NiFi is the better answer, use NiFi. We enable that for you. One thing to note is that this isn't a particular endorsement. It's impossible to fit every single tool that exists out there into these things, but these are just some ideas that you can look at to get a sense of what kind of tools are out there to help you with these. The next tenet is the preservation of original source data, right? Being able to store data and have it be the golden copy of data, right? The ground truth copy of data. The raw data upon which it is never erased, and anything that is created from it needs to be written to a new data set, right? And this also entails being able to manage the life cycle of that data, right? Let's say you have a requirement to write only once, ever, and read many times, and you can never delete it, right? That's a very common requirement for some agencies out there. And so we can do that with Glacier Vault and S3. Capturing data change is also a very important requirement as well, right? Sometimes you need to look at how data is actually changing as you ingest it. So tools such as NiFi and StreamSets help with that. They can actually capture the change of data as an actual construct, and you can use that to help capture that change. Metadata capture is very important, right? Being able to capture the data about the data, being able to say, this data is owned by this cost center and was created by this analyst and was derived from this data set, things like that. And being able to catalog that data as well as search on that data is one of the key constructs that you need to have for a data lake. Managing governance, security, and privacy. This is a big one, right? People want to know, how do I secure my data? How do I manage who has access to my data? How do I, say, have column-level security on my data, cell-level security on my data? How do I, say, federate against my users in Active Directory and say, only this group has access to these columns in my data? These tools can help with that. Self-service discovery, search, and access, right? Being able to then search and then access that data, right? Searching by itself isn't that helpful. Hey, there's data out there. It's somewhere out there, but I can't access it. This is where you can actually get that sort of mechanism through which you can say, I found this data. Now I want to put that data into, say, SAS for analysis. Managing data quality. This is a big one for a lot of customers, right? How do I know my data is actually clean? How do I know that this is actually good data? So there are a huge suite of products out there that can help with that, as well as our own services as well. Preparing for analytics, right? I was talking about how that 80% of time is spent on analytics. These tools here help with speeding up that process, help with figuring out, okay, I need to process my data. I need to make it into a format that is consumable. I need to harmonize my data. How can I do that? These tools can help. And then orchestration and job scheduling, right? When you're starting off with this kind of stuff, you typically are playing around with a single cluster on EMR, or you're playing around with a couple of nodes here and there with some other tool. But as you scale up, this actually becomes kind of a management nightmare, right? Because you need to figure out a way to automate this in a manageable way. You need to figure out a way to schedule jobs. You need a way to say, okay, on the start of every business day, I need to process these data sets, and they need to go here. Oh, by the way, I need to tag them with this metadata and ensure that all security controls are in place. These tools can help. So I'm going fairly quickly. There's a lot, and there's also these two gentlemen here. But I do want to go back to this part right here and note that every single thing I talked about there does map to these services, right? And if you find that one of these services doesn't exactly fit your business requirements today, then there's a huge suite of partner products as well as third-party open source toolkits as well that can help you. So one last thing before I go is security and compliance, right? Everything comes back to security. Security should be your #1 priority. And I want to cover that right now with regards to data lakes. So IAM, in the Identity and Access Management, is our service, AWS service, that we provide to help users manage their AWS infrastructure. So you can manage users, groups, and roles. You can have federation with OpenID and Active Directory. You can have temporary credentials. I implore anyone that's seriously looking at security in the data lake to understand this very well, because lots of great things can happen if you understand it quite well. So for example, if I have a requirement for HIPAA data, right? And I want to say, I only want a certain subset of users to access my data. You can apply a simple policy just like this against that prefix that you see down there under that resource condition to say, if this data is tagged as HIPAA, this person can have access to it. In terms of compliance, we have a huge suite of compliance that you can see here. And if you have a particular interest in one of these, in the interest of time, I do encourage you to look online on our website to gain more information around it. Of particular interest to a lot of people here is probably FedRAMP. So there's a huge wealth of knowledge on our public-facing website around how we address FedRAMP and which services are under scope for FedRAMP. So what are some best practices for security? So let's talk about the classical question of multi-tenant versus single-tenant, right? Historically, most, if not all organizations had a multi-tenant environment set up, say Hadoop environment set up, where you had a bunch of teams touching a single Hadoop cluster. And the key goals here are to ensure that each user that touches that cluster only has specific access to their designated objects in S3, the Redshift clusters they have access to, EMR clusters they have access to, things like that. And you also want to be able to facilitate data sharing between those teams in a secure way. So there are a couple ways you can do that. So fine-grained data and resource ownership is really what it all boils down to, where you have teams that share S3 buckets and clusters. But the issue with this approach is that it's actually quite complex to maintain any sort of access control in a manageable way. And the unfortunate reality is that as people come from on-prem to the cloud, they're taking along that old way of thinking where everyone must have a multi-tenant sort of architecture. And the issue here is that the management just becomes a nightmare. You end up with teams that have specific access to resources, but you need to make sure that Team Y only has access to that little subset of data in that cluster, and Team Z can only have that level of access in that cluster. One thing to consider is that blast radius is a concern. So for example, if Team Y somehow got access to the rest of the environment, they have free reign over anything in that shared environment. The better approach, in my opinion, is to have a coarse-grained model of ownership where teams own entire resources. So in this case, say entire S3 buckets and clusters. Ownership should be segregated by AWS accounts. And by doing so, by minimizing the blast radius in this way, by compartmentalizing users and groups in this way, you really make access control easier to set up and maintain, and your security folks will be happier as well. There's a lot less writing that you have to do in your documentation to say that this group is controlled against this environment on these resources by these mechanisms. Whereas if you can just split it out into, say, coarse-grained kinds of models, it's quite easier. So this is suitable for autonomous teams. I'm not saying this is the best model, but if you can, do this. Another thing to look at that's very important is configuring Amazon S3 permissions. Make sure that your policies on your buckets are configured properly, right? The leading cause of data exfiltration from S3 is because someone didn't configure their S3 bucket policy correctly. And because your data is important to you, I want to stress very importantly that if you want to maintain secure controls on your data, you need to make sure that you are having very explicit bucket policies on your resources. So one last little bit of stuff. One thing that a lot of customers start off with is, say, spinning up Hadoop clusters in EC2. And that's great, actually. That's actually a very common model to process data on AWS. So to do so in a secure manner, first, you have to encrypt everything. You want to encrypt everything. Don't settle for someone telling you that, oh, we have performance degradation on something because we are encrypting it. You want to encrypt everything, right? Security should be your number one concern. And you can do this via a variety of mechanisms, and actually EMR makes it easier to do this. So traditionally, being able to secure data in your data lake via Hadoop-based, say, mechanisms is actually quite hard. And what EMR does is it makes it easier to secure data lake. We actually make it with a couple clicks or a very easy CLI command to configure your cluster such that they are secure versus the old approach where you had to individually configure every single application on your Hadoop cluster to make sure it was secure. One new feature that came out just last week is EMR 514 supports the ability to audit users who run queries against S3 through EMRFS, which is the mechanism through which you query data on S3. And it pushes the user and group information to audit logs on CloudTrail. So for any security folks in the room who want to audit actual transactions against S3 objects, this is what you want to look at. And besides auditing, EMR provides a bunch of other features such as consistent view, managed security configurations, which I talked about before, and fine-grained authorization at S3 on the EC2 role level. And optionally, EMR does integrate with frameworks such as Apache Ranger. So if you do want to have an additional layer of control, take a look at doing that as well. So bringing it all together, you note that this is actually that old slide that I showed you before, but there's a new layer here that shows additional tech stuff that you need to have for the data lake. So you need to have that security and governance layer, right? Concern number one. And then you also have the data catalog layer as well. So I'm passing it on to now Dr. Naik to talk about the US Census EDL.
Thanks. Hopefully the mic's on. So I think Tony gave you a great sort of the ground of how you can achieve establishing a data lake in the AWS environment. Now, from an implementation side, I think the question always comes, okay, how do you convert your business folks, okay? Many of you may be talking to your business side to say, hey, we have all this capability. How can I make it possible? So I engage with AWS Envision engineering team to try to make sure that what is possible. And Tony talked about the technical side. Let's talk about the business side. So at Census, we get massive amounts of data. Many of you may be aware of only about the decennial census, which we conduct once every 10 years. But besides that, we conduct about 103 other surveys. We have statistics which come out about population, economy, businesses, everything we feed to various decision makers in the government side and the private side. So what that has led to, nothing wrong, is just that we have done it individually. We've done it as single instances, single surveys, and this has led to a decentralized data management process, which means I have multiple copies because sometimes I need to share the data amongst different groups. I have a decentralized stewardship. I don't have standardized metadata, and then there's difficulty to share across the board. The other problem is processing and analytic. So you have code-intensive platforms. I don't know how many of you are using, actually, let's take a poll. How many of you are using SAS in your environment? How many are using Oracle? Okay? Have any of you tried transferring that data into some other platform? That's part of the problem. So you have to have proper curation. You have to make sure that you understand what is SAS doing to the data. And so Tony mentioned about lineage. He mentioned about the iterations. Well, we need to keep track of that to make sure that we know what is going on. And this is also not just of the data, but it's also of the code, so that we can reproduce the results and make sure that we are giving the right results in case there was a change in the logic. The third part is the decentralized data storage. I'm sure many of you, sure, it's all in my data center. I'm not saying that it's not in my data center, but they are separate buckets. They are separate buckets. They are separate storage areas. We are managing it all in the data center, but it is still decentralized. We give storage to each entity. Okay? Now, AWS does the same thing. We are all multi-tenants. Each one of us customers, we have our own storage, but now this is aggregated because each project needs its own storage. Most data have file access control. So Census gets all types of data. We collect our own data, we get tax data, we get HIPAA data, we get data from various federal statistics organizations. And so there are laws called CIPSIA, which basically prevent us from giving access to data. And therefore, we create these silos of having data sort of managed individually. And that is not scalable. Then, I know many of you may be facing this, is the whole notion of security and privacy. Security, been in this business for too long, security is always at the end. It is an after effect. Okay? Privacy. Guess what? the whole federal government is based on this privacy because this privacy is the public trust that we provide to the public when they give us their data. Okay? We are not impacted financially, but we are impacted from a public trust standpoint. And that's a huge issue. So, and then the last part is the technology constraints. So the first 4 were more on the business side, but then there is the technology constraint, which is actually shared both by the business and the IT organization, because the business is saying, I want better tools, I want newer capabilities. Everyone has heard about big data. It's the latest buzzword, but we've been living it for quite some time. And people are wanting more capabilities, more avenues to apply technology. So this is a huge problem of getting access to the most current version of software or tools for the business side. So I presented to AWS, and one of the key points was the fact that, and AWS has done a good job. I don't know how many of you are aware. I think the first instance of a data lake was built by FINRA, but it was built with all AWS capability. So the challenge I presented to AWS was, I don't want to use only AWS capabilities. We want to use other open source big data platforms. We want to use existing COTS products. And why is that? Because that gives us an easy mode of transition from where we are today to the new side. You cannot have a switch and tell the business, oh, just start using the new tools. They're going to say, where's my old data? Where's my old code? I need to get access to that. And so we have to provide a transition mechanism for that. So the proof of concept was to build a small interface. We ran using some custom products, COTS products. We used some of the controls. It was a very simple, small-scale capability. But then we used actual data. These are actually data that we had published. So there was no sensitive data in this. And then we also used the legacy SAS code that was applied to that data. And we said, let's start using that, using the tools that Tony talked about. And then here is the beauty. We did prove, and we presented it, and Al is going to show you how. We did manage to show that we could centralize the data. There would be only one instance of the data. So even if there are 5 users of the data, I don't have to make 5 copies. I will make only 1 copy and let the 5 users access that copy. We will keep the data lineage. So as changes are made to data, we will track it. And we can share or link the data between projects or research or our directorates, provided the security and privacy allows them to get access. So the security and privacy is built into it. Processing. This was basically processing the data using code intensive. So those who have used SAS, you know how intense it is to use SAS, how much power you need to actually process the data. We managed to do that. One of the other things we managed to do was we separated the data from the code. So SAS, there are different implementations of SAS. One of the implementations of SAS is where SAS actually handles the data all along. And we separated it out so that the data could live by itself and be used by other platforms. And then the reproducibility of results was the fact that we had the data, we had the code, we had all the lineage tracked in one place. The next thing, of course, was the fact that if we were using the cloud, we were using the S3 or Hadoop. In our case, we were using Accumulo. That gave us the centralized data storage, Apache Accumulo. And then it also gave us not only row and column, but it gave us all the way to the cell-level control. So we were mixing data. We were mixing our census data with tax data. And Tony mentioned all the different securities. Guess what? We have to apply all of them. And so everything was encrypted in motion, at rest, and we controlled access. The best was the fact that we had centralized all the security. It was all in one place. We didn't have to monitor it. Okay, who's made copies? Where is the copy of the data? We keep track of all the data in one place. Now, the data lake is not a centralized data warehouse in terms of the traditional sense. It is more of a centralized logical data warehouse. It can handle all sorts of data. And that is what we were trying to achieve here. And of course, we have auditing and usage monitoring because we are billing. So we can audit and monitor usage, not only from an operational standpoint, from a performance standpoint, but also from a security and access control standpoint. And the technology capabilities. The beauty of the proof of concept was this notion of providing on top of the FedRAMP certified environment that AWS provides, we could add a census certified platform as a service environment that the users can use. There's tighter integration between storage and compute because my computational platform is very close to the data handling platform. And I have the ability to handle very large data sets and use some of the newer tools. The business gets to use newer tools like R, Python, or Spark going forward. And then, of course, there's a cost chargeback model. So I don't know how many of you are aware of the 6 Rs. These are the different ways you can transition to the cloud. The proof of concept enabled us to basically monitor and validate 3 of the Rs of existing data. So we did not have to do major re-architecting. We just did a re-platform and a refactor, and that was a huge win for the business. The mission we have is we are basically saying we want to build on the cloud computing with big data and machine learning, but we can take any data, we can take many tools, and it's easier to operate with the notion that we can give better business results, which is better analytics, quality product, and faster time to publish. I'll hand it over to Al, who will walk you through for what we did in this proof of concept.
Dr. Naik, thank you so much for being here today. Wonderful presentation. Today, I get a chance to join the data lake pattern discussed by Tony with the actual business requirements discussed by Dr. Naik. And we will see how it all comes together in a data lake implementation that we developed as a proof of concept for the US Census Bureau. What we find is that the data lake pattern is common across a lot of data lake implementations. But what's interesting, what we really find interesting is that data lake implementations are all unique in their own ways. Why are they all unique? This is because of specific requirements by the customer, right? All customers have different requirements, and that drives architecture towards certain architectural decisions. It could be data access, it could be security, it could be data lineage, it could be integrations with other systems. All of those specific requirements from the customers drive their data lake implementations towards a certain uniqueness in them. So let's take a look at the specific requirements that we received for the data lake proof of concept for the US Census. The first one is column-level access control with cell-level capability. I'm sure you're all familiar with the with the column-level access control. This is when you lock down the whole column for access to a very particular user or maybe a group of users. Cell-level capability would mean that you would lock down a particular cell within that column. This means that if this is the social security number of the president, for example, you would want to lock down that access because it's very sensitive. Could be a social security number of a general, could be any other sensitive information, but it needs to be locked down on the cell level, not just the column level. So for the specific requirements, we looked around at solutions from the partner network as well as open source. And we found that Apache Accumulo fits our needs for this particular requirement. And this is how our architecture was influenced by this requirement. The next requirement is central storage. Now, what could we use for central storage in AWS? Anyone? Well, Amazon S3, right? Amazon S3 is at the heart of each data lake, and it's a good choice for it. The next one is data lineage at macro level. It's really important for businesses to understand who created the data set, who uploaded the files, who changed the data set and uploaded new files, who analyzed the data set, and where the results are stored. So this is the kind of metadata that we need to store somewhere. And a really good choice for it is DynamoDB. LDAP-based user security and permissions. We have AWS Directory Service for this, so we can map to that. We also needed to provide a choice of the Hadoop infrastructure for this particular data lake. So we provided the choice between AWS EMR, which is Elastic MapReduce, and Hortonworks. We needed to provide the ability to run legacy SAS scripts on SAS 9.4. And so we had to have SAS in the infrastructure as well. The next requirement is on-demand infrastructure of analytics jobs. AWS platform is perfect for it, right? You can scale up or down as you need, and you can pay for only what you use. And the last specific requirement we had was cost tracking for each analytics job. It's really important for businesses to do cost tracking of how much it costs to run this particular analytics routine. So we could use AWS pricing list APIs for this. So this is how our solution was influenced by these specific requirements. So let's take a look at the solution architecture. We have data sets and analytics scripts in Amazon S3, which is typical for a data lake. Then we have a serverless web application. The UI is stored in Amazon S3. Then we have REST APIs fulfilled by Amazon API Gateway. AWS Lambda runs the business logic for us. And as we talked about it, the data lineage and other metadata is stored in Amazon DynamoDB. Of course, we also use CloudFormation for automation of deployments, AWS IAM for restricting access to AWS infrastructure, as well as CloudWatch logs for logging, and AWS Directory Service to satisfy the need for LDAP security and permissions. Now, what is missing in this picture? We need on-demand infrastructure for the analytics job, right? So when the user selects the analytics job and runs it, here's what happens. We spin up resources on demand for this particular analytics job. We need to run the Hadoop platform. So based on the user choice, we either spin up Amazon EMR, which is Elastic MapReduce cluster, or we make a call to Hortonworks CloudBreak to spin up a Hortonworks cluster. With either cluster, we install Accumulo on top of the cluster, and Accumulo provides that security control that we need to lock down the data for the user. And then we hydrate Accumulo with the data set that the user selected to analyze. And then we label the data as we hydrate Accumulo with security labels to know what data is accessible for this user. Then we have Hive layer on top of it. Hive has JDBC compliant endpoints, so it's easy to connect other tools with it. And this makes it possible to run SAS analytics against this endpoint, as well as other analytics scripts. At the end of the analytics routine, the results are stored back to S3, and they can become new data sets that are curated in S3 in the data lake. And at the end of the full completion of the job, all the resources shut down, so you don't have to pay for them as you no longer need them. So before we do a little demo, I'd like to talk about the functional flow. The functional flow is implemented in an App Store-like concept, where the user gets a chance to select the data sets that the user would like to analyze, then select the analytics script to analyze those data sets. Select the analytics platform as we discussed between EMR and Hortonworks. Then hit the submit button. The magic happens. The analytics job runs, executes, and stores the results to S3. And then those could become new data sets. So the solution demo, who's excited? Yes, cool. So this is the UI for the data lake for the US Census. Let's go ahead and log in. As we log in, it will call LDAP, the directory service, which is one of the requirements. Get the security and permissions. Here's the list of data sets that are curated in this data lake. And we could add a data set from here, upload the files, add the metadata to the data set. But let's take a look at the existing data set. So one of the requirements was data set lineage. We can see who it was created by, when it was created, the size of the data set, as well as the cost to store it per month. And this is using the price list API. So it's updated. Owners and who's allowed access. We could start the job from here, but let's set the restrictions on this data set first. Here are the details of the data set we selected. We still see the same lineage, the size of the data set, the cost of the data set per month, who was created by and when, the owners and who's allowed access, but down below we see a list of files and permissions. So let's select the first file, and we'll see columns inside that file that are available for permission settings. You can see the listing of the columns, and you can see that all the locks are currently grayed out and unlocked, which means everyone is allowed access to this data. Everyone who runs analytics against it will have access. So let's lock down a reach state column and allow only one user to access it, Hatem. Hatem is my coworker and my friend, so I'm comfortable giving him access. All right, so we locked it down. I'm not Hatem. Only Hatem can access this column at this point, nobody else. As I will run this next analytics job, I will not have access to this particular reach state column. So we're ready for the job workflow. If you remember, it's the App Store concept where you select the routine and the data set, and you confirm and start the job. So let's select this routine to run. Then we see the files inside this data set, and we select the files that we would like to analyze. So let's just pick the first one for the demo. This is the file that will be analyzed by the analytics routine. And the last screen in the wizard is we get the platform choice between EMR and Hortonworks. Let's do EMR first, and then we'll do Hortonworks in the next job. We can leave the resources running if we need to at the end of the analytics routine, but this time let's clean them up so that we wouldn't have to pay for those resources once the job is done. Let's call this job restricted because I don't have access to one particular column or each state. Here's the routine we selected. Here's the data set we selected. This is the file that will be analyzed based on our selection, and the Hive table name is derived from that file name automatically. And now we're ready to submit the analytics job. This will call the EMR API, and it will spin up the 6-node cluster for EMR. This is on-demand infrastructure. And we can see that the job was submitted successfully. It's starting now. And while it's spinning up, let's run another job in parallel so that we could run multiple analytics in parallel to use the power of the cloud. So let's go ahead and pick the same data set. And this time, we will remove the restriction on the column that we set it on. So this column was locked down. We'll remove the user. We'll disable the lock. And we'll save the change. Now all columns are unlocked. And now I have access to all the data. So we'll select the same routine. We'll select the same data set, and we'll select the same file within the data set to analyze. The only difference is now I have access to this reach state column, right? And let's pick Hortonworks for this job. Let's keep the cleanup resources on so that we wouldn't pay for them when we don't need them. The job name will be unrestricted at this point because I will have access to a reach state data set. And then the same routine, the same data set, let's submit the job. The job submits successfully, and we see Hortonworks as the platform that it will run on. This will also spin up a 6-node cluster for Hortonworks. And since we only have a few minutes left, let's skip ahead to the successful completion of the job. This is when the job completed successfully. And the first one is Hortonworks, the second one is EMR. And we see when it was run, who it was run by, so that's lineage. We see the task name and the status, as well as how long each task took for the cluster. We see the breakdown of the cluster, the cost per each instance, the cost of the SaaS instance, and the type of the SaaS instance. And so all of it was executed and shut down, and the results were stored on S3. Here's the link to S3 where the results were stored and the cost to store it, as well as links to AWS console and EMR logs. At this point, all the infrastructure is shut down for this analytics job, as well as the second one. And we ran them in parallel. So we could use more analytics jobs as needed. And speaking of results, here's the result set from the restricted job. I don't have a reach state output here. I selected the reach state output on the right, and this is the unrestricted output, right? So on the left, I just don't have it at all because I didn't have access to a reach state. On the right, I do have the full reach state output. And to wrap up the demo, I'd like to show you how easy it was to modify the SAS script to work against Hadoop platform. So as we drill down into the routine, you see that there's a source code there, and we passed in a few variables. And literally the only place we had to change was these couple of lines. We only had to point that from the local file to the Hadoop endpoint, the Hive endpoint. And that was the only change we made. We didn't modify the actual script at all, the programming logic. We only pointed it to Hadoop, and that made it work. So a quick word about Accumulo. Accumulo is a distributed key value store with cell-level based access control. It's a single system of record which satisfies our business requirement, and it's fine-grained access control, which returns only the data that the user has access to and nothing else, as you saw in the demo. It was installed via Bootstrap on Amazon EMR, and it can be installed on Hortonworks cluster via Apache and Barry blueprints. We also developed a couple of pieces of code to help us with the implementation. Custom Accumulo loader loads data sets from S3 into Accumulo tables, and as it does that, it assigns column labels as security labels. Custom Accumulo authorization handler checks which labels user has access to in LDAP. And speaking of SAS, we used the Hadoop module, SAS access for Hadoop module to access Hive. It needs Hadoop platform-specific files, such as jar files and site files. And since we had two platforms, we had two sets of those files on SAS. And we needed to use environmental variables that you see on the screen to point to either one set of files or the other to tell SAS which platform we're going to use for this execution. We installed SAS on EC2 instance, created the AMI, which is Amazon Machine Image, and you saw in the demo that there were only minimal changes required to the SAS script just to point to the right data source. And so once we have the AMI, we can launch SAS instances on demand from our AMI. And those SAS instances have an embedded shell script that drives all the execution. So it's a controller script for us. We use the run command to trigger that shell script. It downloads the SAS script that the user selected to run against the data set. It executes the SAS script on SAS. SAS accesses the Hive endpoint, the external tables. It reads from Accumulo. It stores the results locally. And then our controller shell script picks those results and stores them back into S3, which is our central storage. And then everything shuts down. So in summary, we'd like to say that cloud and big data are a perfect match. They provide agility and new opportunities for your business. As you saw in this presentation, AWS provides comprehensive analytics, security, and compliance capabilities. Data lake requirements and use cases vary. And please take a look at AWS Partner Network and open source tools like we did for your specific needs. Thank you.